today we're going to start talking about 3D shapes. And when we talk about 3D shapes, some of these videos are in multi-parts, so make sure you're watching the videos that you need to watch to be successful. So this video is mainly going to go through the basic vocabulary of what a 3D shape is and what they look like and how you can access them on the Virginia formula sheets. So first thing we want to talk about is surface area and then what is volume, because that's what we're going to be doing with 3D shapes. With 3D shapes, we're really going to just be calculating the surface area and the volume. So we really want to figure out what that means. So surface area is when I take all the sides of my 3D shape and I find the area of each of those sides and then I add all those areas up. Okay? So if I were to take all of the sides of this, I would find the area of this hexagon, and I'd find the area of this hexagon, and I'd find the area of the rectangle down here, and the rectangle here, and the rectangle here, and the rectangle on the top, and the rectangle back here. I'd find the rectangle down there. I'd find all those areas, and I'd add them up. So surface area is the sum of the areas of a shape of its faces. Sides of a 3D shape are called faces. So face, and then all the faces around. Those are all called faces. Okay? So I like to think about surface area as I was wrapping a present. How much wrapping paper do I need to wrap that specific gift for somebody? Okay? Volume is how much space inside has the shape. So volume is how much can I fill a 3D shape. So I want to be able to fill a 3D shape with water, with beans, or with anything. And if I want to fill it, that's calculating the volume. So with 3D shapes, we mainly have two different types of 3D shapes. We mainly have prisms and pyramids. And then there's special types of pyramids and special type of pyramids and prisms. We're going to first talk about prisms. Then you might want to go ahead and highlight through your page what you have. So a prism is just a 3D shape where I have two congruent faces, and those two congruent faces I call bases. So a prism has two congruent faces called bases. So if I take a look at these three shapes and I look at my middle shape, the shape that I have two of, I have two triangles. I have the triangle up here and I have the triangle back there. That's actually this prism's base. Even though it's not sitting on its base, that's still classified the base because there's two of them. Notice the other shapes that I have are rectangles and there's three of them. Another thing you can always remember is that the bases are always parallel. Bases are parallel to one another, so see how they're never going to touch? So that's how you also know what the bases are. So if I look back at my middle shape's bases is triangles, so I would call that a triangular prism. My last shape, the shape that I have two of that are parallel from one another, are the hexagons here and here. So this is what's called a hexagonal prism. And if you look at your first shape, it's nothing but rectangles. So in this one, it doesn't really matter which is your base because they're all rectangles, but we call this a rectangular prism. So if I take a look at these three vocabulary words, let's first talk about lateral faces, and then I'm going to show you an interactive page. So lateral faces, they are the faces that aren't the base. So in a triangular prism, they'd be these three rectangles as sides. Okay? Lateral faces are the sides of the prism that are not the base. So if you look at this rotating triangular prism, my triangular prism, it doesn't like it when I click it. The The two sides that are parallel are the triangles, and then my lateral faces are the rectangles. Rectangular prism looks like that. Pentagonal prism, notice my pentagons are my base, and then my lateral faces are the rectangles. And then here's an octagonal prism. And if you notice in the bottom right corner, this is the net of a prism, which just means if I were to cut along the seams of a prism, this is what it would look like. Pentagonal, and then here's the rectangular, and here's the triangular prism. Okay? So if I come back and I want to calculate the lateral area. Lateral area is just the area without the bases. So it would be if I were to find the area of those three rectangles and add them up. And this is going to come into play when we're talking about composite figures, which is when I put two 3D figures on one picture. Pyramid, that's the big one. Pyramid, I meant perimeter. Perimeter. A lot of times the formulas on your formula sheet are going to have the letter P, and it wants you to calculate the perimeter. That does not mean you add up all of the sides of all of your sides of your 3D shape. Perimeter, when I'm asking for the perimeter, I just want to find the perimeter of one base. So in my triangular prism, I would find the perimeter of one triangle. Hexagonal prism, I would find the perimeter of one hexagon. Okay? So if I go ahead and I now talk about cylinders, cylinders are a prism. They just have what shape as their base? Circle. So a cylinder is a prism with a circle base. So now if we talk about pyramids, pyramids have one base, and their one base then has lateral sides, and their lateral sides all meet at a common point, and that we call a vertex. So a pyramid has one base, and all lateral faces meet at one point. And that point is called the vertex. That's what the vertex is. So if I come over here and I look at a pyramid, let's watch wait for it to load. Here is a triangular pyramid where I have a triangle for a base. Here's your rectangular pyramid, right? The rectangle is my base, and notice then when I open it up along the vertex, it kind of looks like a sun. Here it looks like a star when it's a pentagonal pyramid. And then a hexagonal pyramid is right there. So if we now talk about what it means to be slant height, the letter we use for slant height is letter L, and they already use the letter H for height. So when I want slant height, they just use the letter L, and I honestly don't really know why they use the letter L. But it is the height of a lateral face. So if I were to find the height of this lateral face, it'd be right there. And that would be, I would call it. If I wanted to find the height of the pyramid, that would come down in the middle, and that would be H. And if you flip your page, actually, and you look at a cone, I have a really good picture of it. A cone is just a pyramid with a circle base. And notice here, L is right here. This wants to work for us today. Oh, there we go. So that's my slant height. So then this would be my height of my cone. And then remember R is just the radius. And the last thing I want to talk about is a sphere. A sphere is just made up of infinite number of circles. So infinite number of circles are in a sphere, made up of infinite congruent circles. And the other thing I really want to point out about a sphere is that all the points on the sphere are equidistant to the center. So that means I have so many equidistant radii, and they're all congruent. Okay? And if you go over and you look at your formula sheet, this is the formula sheet that you're allowed to use on the Virginia SOL. This formula sheet gives you all of your basic shapes. It gives you your two-dimensional shapes, and then it gives you your three-dimensional shapes. Here are your prisms, and then you go into your pyramids, and this works for all pyramids. And if you look at these formulas, you're going to notice there's letters you don't know what they mean. But if you scroll to the back on the abbreviation side, you have a whole list of abbreviations. So B is area of the base, C is circumference, lateral area, perimeter. The only thing it doesn't have on here is L, which is slant height, so you might want to add it. So the second video is going to go through and it's going to show you how to actually calculate the surface area and volume of these types of shapes.